What if traveling to space was as simple as taking an elevator ride? Picture this, a colossal cable stretching from the surface of Earth far into the cosmos, connecting our planet to the stars. This isn't science fiction, it's the concept of a space elevator, a bold, revolutionary idea that could transform how humanity accesses space forever. Imagine bypassing the roar of rocket engines, the clouds of smoke, and the skyrocketing costs, all for a seamless journey into orbit. But how close are we to turning this vision into reality? And what would it mean for the future of space exploration, industry, and even life as we know it? Let's unravel the fascinating science, the challenges, and the groundbreaking possibilities behind building an elevator to the heavens. At its core, a space elevator is exactly what it sounds like, a structure designed to transport people and cargo into space, but without the need for traditional rockets. To understand how it works, let's break it down into its main components: the tether, the counterweight, and the climber. The tether acts like the cable of the elevator, stretching from the surface of the Earth all the way up to geostationary orbit, which is roughly 36,000 kilometers above the planet. At this altitude, objects remain stationary relative to the Earth's surface, making it the perfect spot to anchor the tether. On the other end of the tether, far beyond geostationary orbit, there's a counterweight, something incredibly massive, like a captured asteroid or an artificial structure, that provides the tension needed to keep the entire system stable, as the centrifugal forces generated by Earth's rotation balance against the pull of gravity. Now imagine the climber. Think of it as the elevator car. It would move up and down the tether, carrying cargo and passengers from Earth to low Earth orbit or even beyond. The climber would be powered by technology like electric or laser propulsion, avoiding the need for the explosive fuel that rockets require. If you've ever taken an elevator up a skyscraper, you already have a basic sense of how this system might work, except that instead of stopping at the penthouse, this elevator could take you straight into orbit. But of course, the simplicity of this concept belies the extraordinary engineering challenges involved. Take the tether, for instance. To withstand the immense forces of gravity and tension, it would need to be made of a material that's both incredibly strong and lightweight. Steel and other conventional materials just won't cut it. They'd snap under the strain. Scientists have suggested using advanced materials like carbon nanotubes or graphene, which are hundreds of times stronger than steel but still in the early stages of development for applications on this scale. Producing a tether tens of thousands of kilometers long with such precision would require breakthroughs not just in material science but in manufacturing and logistics. While this might sound futuristic, the idea of a space elevator has been inspiring humanity for more than a century. The concept can be traced back to Konstantin Tsiolkovsky, a Russian scientist and one of the early pioneers of astronautics. In 1895, Tsiolkovsky was inspired by the Eiffel Tower in Paris and began imagining a tower so tall that it could reach beyond Earth's atmosphere. While he didn't have the technology to make it possible, his vision laid the foundation for what we now call the space elevator. Later, in the mid-20th century, the idea was revisited and refined as advancements in physics and engineering provided a deeper understanding of the forces involved. The dream of a space elevator has endured because it offers a solution to one of the biggest barriers to space exploration: cost. With rockets, much of the expense comes from the sheer amount of energy required to overcome Earth's gravity, not to mention the waste involved in single-use boosters. A space elevator, by contrast, would eliminate the need for conventional launches, drastically reducing costs and making space more accessible to governments, private companies, and even individuals. It's no wonder this idea continues to capture the imagination of scientists and futurists alike. building a space elevator isn't just about dreaming big, it's about solving some of the most complex scientific and engineering challenges humanity has ever faced. At the heart of these challenges lies the tether, the central component that would stretch from Earth's surface all the way to geostationary orbit. For this to work, the tether must be incredibly strong yet lightweight, capable of withstanding immense forces. Every inch of it would need to endure the relentless pull of Earth's gravity, the centrifugal force from the planet's rotation, and external threats like high-speed micrometeoroids and radiation from space. So, what could we possibly use to build such a tether? This is where advanced materials like carbon nanotubes and graphene come into play. These are no ordinary substances. Carbon nanotubes, for example, are cylindrical structures made entirely of carbon atoms, arranged in a configuration that gives them extraordinary strength. In fact, they are up to 100 times stronger than steel while being only a fraction of its weight. Similarly, graphene, essentially a single layer of carbon atoms arranged in a honeycomb lattice, is known for its exceptional tensile strength and flexibility. These materials have some of the best strength-to-weight ratios ever discovered, making them prime candidates for the tether. But here's the catch: while these materials are groundbreaking on a small scale, we're nowhere near ready to manufacture them in the quantities and qualities needed for something as massive as a space elevator. To give you a sense of the scale, the tether would need to be tens of thousands of kilometers long and nearly flawless in its composition. Any weakness or structural defect in the material could lead to catastrophic failure. Current methods for producing carbon nanotubes and graphene are still in their infancy when it comes to creating large, continuous structures. Scientists and engineers are working on scaling up production and improving quality control, but it's clear that major breakthroughs in material science will be essential before we can even think about weaving the tether. Beyond the tether itself, there's the challenge of anchoring it to the ground and extending it into orbit. The base station on Earth would need to be located near the equator, where the planet's rotational forces are strongest. It would also have to be incredibly stable, likely built on a massive floating platform in the ocean to mitigate the risks of earthquakes and other ground-based disruptions. Then there's the question of the counterweight at the other end of the tether. Some proposals suggest using an asteroid hauled into place or a purpose-built structure positioned far beyond geostationary orbit to provide the necessary tension. This isn't just about brute force engineering. It's about achieving a delicate balance where the tether doesn't collapse inward or snap outward under the immense stresses. And let's not forget the climbers, the actual vehicles that would travel up and down the tether. These would require their own set of technological innovations, from highly efficient propulsion systems to advanced energy transmission methods. Many researchers are exploring laser-based power beaming, where energy is transmitted from ground stations to the climbers as they ascend, eliminating the need for heavy onboard fuel. It's a promising idea, but it requires precision engineering and reliable energy transfer over vast distances. Despite these challenges, experts in the field remain cautiously optimistic. Dr. Bradley Edwards, a prominent advocate for space elevators, has outlined detailed roadmaps for how such a project could be realized. He believes that with sustained investment and focus, the basic technologies could potentially be developed within a few decades. Other futurists argue that the rapid pace of innovation in materials science and robotics means that what seems impossible today could become reality faster than we expect. After all, just a few decades ago, the idea of reusable rockets seemed like science fiction, and today they're a cornerstone of private space travel. Ultimately, building a space elevator isn't just about solving one or two engineering puzzles. It's about assembling a symphony of breakthroughs across multiple fields. From the development of next-generation materials to the mastery of orbital mechanics and power systems, each step will require ingenuity and collaboration on a global scale. But if humanity can rise to meet these challenges, the payoff could be unprecedented. A future where space is no longer a privileged frontier, but an accessible realm for nations, industries, and individuals alike. One of the most compelling reasons to pursue the construction of a space elevator lies in its potential to revolutionize the economics of accessing space. Today, launching payloads into orbit relies almost exclusively on rockets, a process that is not only expensive but also highly inefficient. The cost of sending just 1 kilogram of payload into orbit currently ranges from thousands to tens of thousands of dollars, depending on the launch system. For large-scale missions such as deploying satellites, building space stations, or sending supplies to future lunar or Mars colonies, these costs quickly become a limiting factor. A space elevator, however, could change all that. With a space elevator, the cost of launching payloads could drop by a staggering 90%, if not more. This massive reduction stems from the fact that elevators wouldn't require the explosive fuel and intricate infrastructure that rockets depend on. Once built, the system would run on electricity or laser-based energy transfer, meaning costs would largely be tied to maintenance and operating the climbers rather than designing, fueling, and launching rockets for every trip. This could make space accessible not just to governments and large corporations, but to smaller companies, universities, and even individuals with visionary projects. Imagine how this could open the door for innovation, countless startups experimenting with new satellite technologies, more expansive space telescopes to deepen our understanding of the universe, and even advancements in space medicine or microgravity manufacturing. Entire industries could experience growth like never before. Telecommunications, for instance, already relies heavily on satellites orbiting Earth, but a space elevator would make it far cheaper to launch and maintain these networks. This means faster, cheaper, and more reliable internet and communication services across the globe, including in remote or underserved areas. Similarly, scientific research would take a quantum leap forward. Think of the possibilities: easier access to space for experiments in fields like biology, physics, and materials science, where microgravity environments can yield breakthroughs that are impossible to achieve on Earth. And then, of course, there's the transformative potential for space tourism. Right now, venturing into space is an exclusive privilege, available only to the wealthiest individuals or trained astronauts. With a space elevator, the dream of seeing Earth from orbit or living in a space hotel could become a reality for far more people. Long-term, this could help support the building of orbital habitats, lunar colonies, and even interplanetary travel as humanity continues its exploration of the cosmos. But the advantages of a space elevator aren't just economic, they're environmental too. Rockets, while marvels of engineering, come at a steep environmental cost. Each launch consumes enormous amounts of fuel, often generating significant greenhouse gas emissions and releasing harmful chemicals into the atmosphere. While modern rocket companies are working to improve efficiency and reduce their environmental impact, the challenge is far from solved. A space elevator, on the other hand, could drastically cut down on the need for rocket launches. By eliminating the reliance on chemical propulsion for routine trips to and from orbit, a space elevator offers a far more sustainable way to access space. Over time, this could have a profound impact on reducing the space industry's carbon footprint. It's worth considering whether the long-term economic and environmental benefits of a space elevator could justify the immense upfront costs of building it. Constructing a structure of this scale would require a global effort, with potentially trillions of dollars invested in research, materials, construction, and infrastructure development. But if successful, the eventual cost savings and the environmental advantages could pay dividends for centuries to come. humanity would gain a more sustainable, affordable pathway to space, enabling unprecedented growth in science, innovation, and exploration. So, would the financial and technological hurdles of building a space elevator outweigh the extraordinary opportunities it promises? While the debate continues, one thing is certain: the potential economic and environmental impacts of such a system could redefine the way we see and interact with space, making it not just a frontier for the privileged few but a shared resource for all of humanity. Imagine a future where humanity's reach extends far beyond Earth, where lunar bases thrive, space stations orbit as hubs of activity, and missions to Mars are no longer daring ventures but routine operations. A space elevator could be the key that unlocks this future, acting as a bridge between our planet and the wider cosmos. By offering a reliable, cost-effective, and energy-efficient way to transport supplies, equipment, and even people into orbit, space elevators could transform deep space exploration from an ambitious dream into a sustainable reality. First, consider the challenge of building infrastructure in space. Whether it's assembling modular space stations, constructing habitats on the Moon, or preparing for long-term missions to Mars, one of the biggest obstacles is the sheer logistical burden of launching all the necessary materials from Earth. Rockets, while powerful, are costly and limited in how much they can carry. Each kilogram of cargo requires exponentially more fuel to escape Earth's gravity, creating a bottleneck that stifles large-scale space projects. A space elevator would completely change this calculus. With a steady, scalable flow of materials lifted into orbit at a fraction of the current cost, the construction of orbital shipyards, lunar outposts, or interplanetary spacecraft could happen faster and more affordably than ever before. Imagine the assembly of a lunar base. Instead of relying on multiple rocket launches to deliver equipment piece by piece, materials could be sent up the space elevator to an orbital transfer station. From there, robotic spacecraft could ferry the supplies to the Moon's surface. This streamlined system would not only simplify logistics, but also decrease the risk and environmental impact associated with dozens of rocket launches. Over time, this could pave the way for permanent human settlements on the Moon, complete with research facilities, mining operations, and thriving communities. The same principle applies to missions to Mars and beyond. One of the biggest challenges of interplanetary travel is launching massive spacecraft with enough fuel, supplies, and equipment to sustain a crew for the journey. Instead of launching everything at once, a space elevator could serve as a staging ground. Spacecraft could be assembled and provisioned in orbit, bypassing the need to fight against gravity with every individual component. This construction-in-orbit approach would make missions more efficient and cost-effective, accelerating humanity's ability to explore the Red Planet and other destinations in our solar system. Space elevators could also serve as a foundation for building larger, more advanced space stations in low Earth orbit. These stations could act as logistics hubs, research centers, or even commercial destinations. For instance, a station positioned as a hub for space travel could serve as a stopover point where explorers refuel, resupply, and prepare for missions that take them further into the solar system. This kind of infrastructure would make space exploration more modular and adaptable, working much like international airports do today. Instead of treating space exploration as a one-off endeavor for specific missions, it would become an interconnected system of transport and knowledge sharing. But achieving this vision isn't just about technology, it's about global collaboration. A project of this scale would require the combined efforts of nations, industries, and scientists from around the world. No single country could realistically tackle the engineering, financial, or logistical challenges alone. Imagine a world where countries pool their resources not to compete in space, but to build a future that benefits all of humanity. Collaborative efforts could ensure that the space elevator becomes a tool for shared progress, providing access to space for developing nations and fostering international partnerships in space exploration and science. The potential impact of a space elevator on our capacity to explore and settle the cosmos is nothing short of transformative. It would be the ultimate gateway, a ladder to the stars that eliminates the constraints of traditional launch systems and opens up new possibilities for innovation and discovery. By removing the limitations of cost and logistics, humanity could truly begin to establish itself as a species that lives and thrives beyond Earth, united in its exploration of the final frontier. Building a space elevator isn't just a technological challenge, it's a test of humanity's ability to come together and collaborate on an unprecedented scale. Such a monumental project would require contributions from countries and private companies around the world, pooling resources, expertise, and funding to make the vision a reality. But as promising as this sounds, it also raises a host of geopolitical and legal questions that demand careful consideration. Can humanity overcome its deep-seated political, economic, and cultural differences to construct a shared gateway to the stars? To start, let's consider the sheer scale of what a space elevator entails. Unlike the International Space Station, which orbits Earth and is maintained by a handful of contributing nations, a space elevator would be a fixed, physical structure originating on Earth's surface and extending into space. This raises immediate questions about ownership, jurisdiction, and usage rights. Who would control the elevator? Would it be owned by a single nation, a coalition of nations, or a private entity? And how would access be regulated to ensure equal opportunities for all parties, including developing nations that may lack the resources to directly contribute to its construction? These questions aren't just hypothetical. History has shown that international collaborations in space can be both successful and fraught with tension. The International Space Station is a prime example of what's possible when nations work together. Since its inception, it has brought together 16 countries, including the United States, Russia, Canada, Japan, and European nations, to create and operate one of the most complex engineering projects ever built. Despite geopolitical tensions on Earth, the ISS has remained a symbol of peaceful cooperation, enabling groundbreaking scientific research and fostering goodwill among participating nations. However, the challenges haven't been insignificant. Funding disputes, disagreements over contributions, and political strains have all threatened the ISS at various points in its history. Translating this collaborative spirit to a project as massive as a space elevator would magnify these difficulties. For instance, would major spacefaring nations like the United States or China be willing to share control over such a critical piece of infrastructure? Could smaller nations or private companies secure a meaningful role in its development, and how would profits or access be divided among contributors? Another major concern centers on the potential militarization of a space elevator. As a strategic asset, it would offer unparalleled access to orbit and beyond, making it a valuable tool not just for exploration but also for defense. This raises fears that a space elevator could become a point of conflict rather than cooperation. International laws like the Outer Space Treaty, which prohibits the placement of weapons of mass destruction in space, would need to be expanded or revised to address the unique challenges posed by a space elevator. Safeguards would be needed to ensure that the structure couldn't be monopolized or weaponized by any single entity, preserving its role as a tool for peaceful exploration. And then there's the question of fair access. If a space elevator were built, would it be open to every nation, or would access be limited to those who contributed to its development? In an ideal world, such a structure would function as a global resource, benefiting all of humanity. But that ideal would require unprecedented levels of diplomacy and trust among nations, many of which are currently divided by competing interests. The issue of funding alone could divide nations, with wealthier countries likely bearing the brunt of the cost but potentially demanding more control as a result. Private companies would add another layer of complexity. Space exploration has increasingly shifted toward the private sector, with companies like SpaceX, Blue Origin, and others leading innovations in launch technology. Their involvement in a space elevator project could drastically accelerate development and reduce costs, but it would also raise questions about corporate influence over something as fundamental as access to space. Could private companies, motivated by profit, work alongside governments to ensure the elevator remains a shared global resource? Or would their involvement lead to commercialization and exclusivity, making space less accessible rather than more? Despite these challenges, there's reason for optimism. Humanity has shown time and again that it can unite around shared goals when the stakes are high enough. The construction of the Panama Canal, the eradication of smallpox, and even the creation of the United Nations demonstrate what's possible when nations put aside their differences for the greater good. A space elevator, with its potential to revolutionize access to space and benefit all of humanity, could serve as a new rallying point for international collaboration. Ultimately, the question isn't just whether we have the technology to build a space elevator, it's whether we have the will to work together to make it happen. Can humanity rise above its divisions to create something that belongs to everyone and serves as a stepping stone to the stars? The answer to that question will determine not just the future of space exploration, but the future of humanity itself. When comparing space elevators to traditional rockets, the differences are as vast as the distances they aim to conquer. While rockets have been the backbone of space exploration for over half a century, space elevators present an entirely new paradigm for accessing space. Each approach comes with its own unique set of strengths and challenges, and understanding how they complement one another could shape the future of space travel. Let's start with cost, arguably the most compelling advantage of space elevators. Rockets are enormously expensive to build, fuel, and launch. The cost of delivering even a single kilogram of payload into orbit using rockets can be staggering, often reaching tens of thousands of dollars. For example, conventional rockets like the Saturn V that carried astronauts to the moon were once-off vehicles, meaning the entire system was discarded after each flight. While newer rockets such as SpaceX's Falcon 9 have introduced partial reusability, costs still add up due to maintenance, fuel, and the wear and tear of repeated launches. In contrast, once a space elevator is constructed, it could enable repeated trips into orbit at a fraction of the cost, powered by electricity or laser-based systems rather than rocket fuel. This cost efficiency could democratize access to space, making it feasible for more nations, universities, and even startups to send payloads into orbit. Safety is another critical distinction. Rocket launches are inherently risky. They involve igniting massive amounts of fuel, producing explosive thrust to escape Earth's gravity. Even with modern safety measures, a single malfunction can lead to catastrophic failure, as history has shown. Space elevators, however, promise a far less volatile alternative. Without the need for combustion-based propulsion, the risk of explosions or failed launches would be virtually eliminated. This could make space travel significantly safer for both humans and cargo, fostering trust and expanding access to space for more participants. Scalability is where the potential of space elevators truly shines. Once the infrastructure is in place, space elevators could handle a high volume of transport, operating continuously to deliver payloads into orbit. This kind of scalability is difficult for rockets to achieve. as each launch requires weeks or even months of preparation, including inspections, fueling, and mission-specific adjustments. Space elevators, by contrast, could function more like a conveyor belt, providing a steady, predictable flow of goods to space. This would be particularly valuable for building large-scale projects like orbital space stations or lunar habitats, where repeated transport of materials is essential. That said, space elevators aren't without their challenges. Their primary drawback lies in the monumental engineering hurdles and upfront costs associated with their construction. As mentioned earlier, developing materials strong enough to build a tether stretching thousands of kilometers into space is a problem scientists are still working to solve. Additionally, the construction process itself would likely take decades and require unprecedented international cooperation. Rockets, by comparison, are a proven technology available now. They are adaptable, capable of carrying different payloads, and can be rapidly deployed for urgent missions, qualities that space elevators currently can't replicate. This adaptability makes rockets indispensable in scenarios where speed is critical. For instance, during emergency missions, like launching a satellite to replace a damaged one or delivering supplies to a crew stranded in space, rockets are unmatched in their ability to respond quickly. Rockets also excel at delivering heavy payloads to destinations far beyond Earth's orbit, such as the Moon, Mars, or the outer planets. A space elevator, while ideal for routine trips to low Earth orbit, would likely struggle to handle the sheer mass and energy requirements needed for deep space missions. In such cases, rockets would remain the technology of choice. Given these differences, space elevators and rockets aren't necessarily competitors. They're complementary tools in humanity's quest to explore the cosmos. Imagine a future where space elevators handle the routine transportation of supplies and lightweight equipment to orbital stations, while rockets focus on pushing the boundaries of exploration, carrying astronauts and heavy cargo to distant worlds. For example, a space elevator could deliver components of a Mars-bound spacecraft to orbit, where they'd be assembled and launched on a rocket-powered deep space journey. This partnership could drastically reduce the costs and risks associated with such missions, opening new possibilities that neither technology could achieve alone. So, rather than replacing rockets, space elevators could coexist as part of a broader space infrastructure. Together, these technologies could form the backbone of a sustainable space economy, one that not only pushes the boundaries of exploration but also brings the benefits of space down to Earth. It's not about choosing one over the other. It's about building an ecosystem where each can play to its strengths, creating a future where humanity's reach extends further than ever imagined. The societal implications of space elevators go far beyond their function as a mode of transportation. They have the potential to profoundly reshape how humanity interacts with space, inspire groundbreaking technological progress, and redefine our cultural identity on a planetary scale. Imagine a world where access to space is no longer the privilege of a few nations or billion-dollar corporations, but something within reach for countries, communities, and individuals. A world where the endless possibilities of space exploration fuel innovation, not just in aerospace but across every field of science and engineering. The ripple effects of such a transformative project could be nothing short of revolutionary. To start, consider how democratizing access to space could inspire an education revolution. Today, the opportunities to directly participate in space endeavors are limited, often requiring decades of training and education or affiliation with elite institutions. But a functional space elevator would drastically reduce the cost of launching satellites, enabling universities, startups, and even high schools to affordably deploy their own experiments into orbit. Students could design and monitor projects in microgravity, learning firsthand the principles of physics, materials science, and biology. This hands-on experience could ignite a wave of interest in STEM fields, encouraging more students to pursue careers in space-related industries. Imagine classrooms around the globe filled with young minds tackling real-world challenges like designing sustainable habitats for Mars or improving energy systems for orbital facilities. But the impact on careers wouldn't stop at scientists and engineers. The construction, maintenance, and operation of a space elevator would require a multidisciplinary workforce creating thousands, if not millions, of jobs across various sectors. These would include roles in advanced materials manufacturing, robotics, software development, infrastructure building, and energy management. Even fields like law, ethics, and policy-making would play crucial roles in shaping international agreements and ensuring the system benefits all of humanity. Space could become a thriving economic frontier, not just for the privileged few, but for people from all walks of life. Just as the Industrial Revolution transformed economies and societies, a space elevator could represent a new era of growth and opportunity for the global population. Beyond the economic and educational shifts, a space elevator could fundamentally change how humanity sees itself and its place in the universe. Right now, space exploration is largely viewed through the lens of science, national pride, or corporate ambition. But with a space elevator granting reliable access to orbit, space could become integrated into everyday life. The stars would no longer feel impossibly distant, they'd become part of our collective reality. This shift in perspective could inspire a renewed sense of unity and purpose, reminding us that we are a single species on a shared planet, reaching outward together. However, such transformative power also comes with profound ethical considerations. Ensuring equitable access will be key. Without careful planning, there's a risk that a space elevator could deepen existing inequalities, concentrating its benefits in the hands of wealthy nations or corporations while leaving others behind. These concerns highlight the importance of developing international policies and agreements that make this technology a global asset rather than a private commodity. How would we ensure fair usage? How could we prevent monopolization while fostering accessibility for developing nations and marginalized communities? These are questions we must grapple with now, well before construction begins. A space elevator has the potential to be a tool for equity, but only if humanity chooses to build it that way. Culturally, a functioning space elevator could also shape how we think about progress and sustainability. Its reliance on reusable systems and renewable energy sources could serve as a blueprint for similar innovations on Earth, inspiring greener technologies and practices in everyday life. Furthermore, by making space more accessible, the elevator could accelerate humanity's exploration of other planets and even the development of off-world colonies. This could spark a cultural shift in how we view our own planet, not as an isolated home, but as part of a much larger cosmic ecosystem. The idea that Earth is not our final frontier, but rather our first stepping stone, could instill a sense of collective responsibility for preserving our world while exploring others. So, what might life on Earth look like with operational space elevators? Picture bustling hubs near the equator, the base stations of these colossal structures, teeming with engineers, scientists, and travelers. Nearby cities would likely evolve into cosmopolitan spaces where technology, culture, and innovation intersect. Space tourism could flourish, with families planning trips to orbit the same way they plan beach vacations today. Satellites designed to combat climate change or improve global communication could be deployed in record numbers. And perhaps most importantly, space would no longer feel like a distant dream. It would be a tangible, integral part of human life. In short, space elevators have the potential to transform society in ways we can only begin to imagine. They could open space to everyone, inspire waves of innovation, and unite humanity in the shared pursuit of exploration. The question is, when we build this bridge to the stars, will we have the foresight and collaboration to ensure it lifts all of humanity? Because as extraordinary as the technology promises to be, its true power lies in how we choose to use it. And that decision will shape not just our future in space, but the kind of civilization we aspire to become. So, where do we stand today on the road to making space elevators a reality? As of now, this concept, while ambitious, is no longer relegated to the realm of pure science fiction. In fact, steady progress is being made across multiple fronts, from advancements in materials science to the growing interest of space agencies, private companies, and academic institutions. The groundwork is being laid piece by piece to overcome the many challenges standing in the way of constructing an elevator to the stars. One of the biggest hurdles, as we've discussed, lies in the development of a tether material strong enough to withstand the immense forces involved. Currently, carbon nanotubes and graphene remain the most promising candidates. While these materials have been produced in labs and are known for their incredible strength, scalability is still a major issue. Producing carbon nanotubes of sufficient length and consistency to form a tether thousands of kilometers long is a challenge that scientists are actively tackling. Researchers in labs around the world, from institutions like the University of Texas to Tokyo's Advanced Institute of Science and Technology, are experimenting with methods to grow longer and more uniform nanotube structures. These breakthroughs may still be years away, but the steady pace of innovation gives hope that we could see this challenge overcome within the next few decades. Beyond materials, there's a growing ecosystem of organizations and thought leaders dedicated to turning the space elevator concept into a tangible reality. One noteworthy player is the International Space Elevator Consortium, or ISEC. This group brings together engineers, academics, and industry experts to conduct research, refine designs, and promote global collaboration. ISEC has published detailed roadmaps outlining the technical and economic feasibility of space elevator projects, providing a blueprint for how we might approach this seemingly insurmountable challenge. Private companies are also beginning to explore the possibilities of this technology. For instance, Obayashi Corporation, a major construction firm based in Japan, has announced its long-term ambition to build a space elevator by the year 2050. While this goal may sound optimistic, Obayashi has already invested heavily in researching the necessary technologies, from tether systems to climber designs. The company believes that advancements in material science and robotics will converge in the coming decades to make their vision achievable. On the tech frontier, companies like SpaceX and Blue Origin, while primarily focused on rockets, are also laying the groundwork for reusable and scalable space infrastructure that could complement a space elevator system. Government space agencies aren't sitting on the sidelines either. NASA, for example, has funded research into space elevator technologies as part of its broader effort to reduce the cost of accessing space. NASA competitions like the Tether Challenge have incentivized researchers to develop stronger, more reliable tether materials. Even if this specific technology hasn't reached its final form, the focus on solving fundamental engineering problems is critical for the eventual realization of a space elevator. So, what's the realistic time frame for seeing a space elevator become operational? Many experts suggest that we're looking at a multi-decade timeline. Early projections estimate that, with sustained investment and a series of breakthroughs in materials and construction methods, we could see the first viable space elevator by the middle of this century, perhaps between the years 2045 and 2060. This timeline depends on more than just technological innovation, though. It will also require significant international cooperation, as no single nation or company is likely to undertake such an enormous project alone. Political, economic, and logistical hurdles must be addressed on a global scale. In the short term, we're likely to see incremental progress that paves the way for the larger goal. For instance, prototypes of climbers, essentially scaled-down versions of the elevator cars, are already being tested. These systems are examining how energy transmission, motor efficiency, and overall stability could work on a smaller scale. Additionally, robotic technologies developed for other space applications, such as satellite servicing or lunar rovers, will likely inform the design of climbers capable of operating on a space elevator tether. Each of these small steps is bringing us closer to turning this once unimaginable idea into reality. Ultimately, the progress we're seeing today signals that humanity isn't just dreaming about space elevators, we're actively working toward them. Step by step, breakthrough by breakthrough, we're getting closer to a future where space elevators could revolutionize how we access and interact with the cosmos. Although there's still a long road ahead, the determination of scientists, engineers, and visionaries is undeniable. The question is no longer if space elevators are possible, it's when they'll become a reality. And given the momentum we're witnessing, that future may arrive sooner than we think. As we bring this journey to a close, let's take a moment to reflect on the profound potential of space elevators and what they represent for humanity. We've explored how this remarkable idea could revolutionize orbital access, drastically reducing the cost of reaching space and creating opportunities that were once unimaginable. We've ventured into the science behind its construction, from the cutting-edge materials needed for the tether to the intricate mechanics of climbers and counterweights. And we've examined how this technology could reshape not just space exploration, but industries, economies, and even cultural perspectives here on Earth. Yes, the challenges are immense, from developing materials strong enough to hold the tether together, to coordinating a global effort to fund, design, and build such a colossal structure. The road ahead is long and complex. But history teaches us that humanity's greatest achievements often emerge from what once seemed impossible. The same determination that brought us the pyramids, the transcontinental railway, powered flight, and the moon landing could one day bring us a functioning space elevator. It's a testament to how far we can go when bold ideas meet relentless effort. The opportunities, though, are boundless. Imagine a world where the boundary between Earth and space fades away, and not as a distant or exclusive frontier, but as an extension of human activity. Routine trips to orbit could become as common as international flights. Students could send experiments to microgravity environments as part of their education. Entire industries could emerge, from orbit-based manufacturing to space tourism, enriching lives in ways we can't even fully comprehend yet. And as we reach for new horizons, we could begin to solve problems here on Earth, uniting nations around shared innovation and fostering a global sense of interconnectedness and purpose. But the true value of a space elevator isn't just in the technology itself. It's in what it symbolizes. More than a physical ladder to the stars, it's a metaphor for the way humanity can rise above challenges, innovate beyond limitations, and dream beyond what is possible today. This concept invites us to rethink what we're capable of, not just as individuals, but as a species, working together to create a future that serves all of us. So I'll leave you with this thought. What role will you play in this future? Will you be an innovator driving the breakthroughs needed to bring this dream to life? A supporter championing efforts to make space exploration sustainable and inclusive? Or simply a dreamer inspiring others with your belief in humanity's potential? No matter the role, every voice, idea, and effort matters. Space elevators remind us that the future isn't just something we wait for, it's something we build together. If this vision inspires you, let us know your thoughts in the comments. How do you see space elevators reshaping the future? If you enjoyed exploring this concept and want to dive deeper into the amazing possibilities of the future, Don't forget to like, share, and subscribe to the channel. Together, let's keep reaching for the stars, one bold idea at a time.